welcome back, Mindsetters. I hope you guys had a refreshing break because there is still more to go through. On the page, lovely stuff, guys. I love seeing so much interaction, so many questions, so much interest. I know you guys are helping each other and actually care. It's nice that you care because then you stand a shot at passing really well. Do you
Absolutely.
want some questions?
Hit me with it. Let's see
Okay.
what we can do.
So we have a question from Nsako, Pleasure Nsako. She asks, I think this is what you're asking. You can send a message to correct us, but she asks, what is the difference between the distance versus time graph and the displacement versus time graph?
That's actually a great question because I didn't really cover it. Remember, distance is a scalar, sweetie. So distance doesn't have direction. So with all of my displacement graphs, if we go right back to the beginning where we looked at the displacement over here, okay, I could draw displacement as a negative value. You would not get that in a distance graph because distance doesn't matter about direction. So the shape of the graph would look the same, but it would never go below the y-axis. Okay, never go below the x-axis, sorry. So it would never be negative. That's the only difference. The shapes look the same, but it just never goes to the negative, basically. Yeah, good question.
Okay, and then there's another one by Mfundo. He asks, is acceleration under a vector or a scalar?
Mfundo, acceleration is a vector. Okay, acceleration can be positive and negative, so it has direction, absolutely. And next year in grade 11, you're going to do a whole thing on Newton's second law. It's a really nice section where we start to do the whole direction of your acceleration in a lot more detail, but it is a vector. Okay, it can be positive or negative depending on the direction, and it's a little harder to see than some of the others because when we talk about a negative acceleration, it doesn't mean that the object's necessarily moving backwards. It just means that the acceleration acts in a different direction to the direction of motion. Okay, so it's definitely a vector.
Okay, and then we have another one by Nsako. What is the difference between velocity and displacement?
Okay. Displacement is the straight line distance in a certain direction from the beginning point to the end point of a motion. So it's a distance, it's in meters. Velocity is how fast you take to do that. Okay, so velocity is like speed, but with direction. So velocity is how fast we get it. So velocity can be 2 meters per second, which tells us that I cover 2 meters every second. Okay, so velocity is a speed with direction. Displacement is a distance. It's a length. Okay.
Okay.
Cool. All right. So we have some problems with equations of motion, and I'm going to show you some ways on how to deal with these problems, grade 10s. They're actually not as difficult as they look. A lot of the times, it's not that you can't do the science. You're just not sure what the question is asking you. So, hint, take out a pen. You start to write things down. It says to us, a train starts from rest. This is important. If something is at rest or comes to rest, it means it is stationary. So if my train starts from rest, my initial velocity is 0. Okay? And accelerates at 1 meters per second squared. Before I go any further, what we're going to do is we're going to write a list. There were 5 unknowns. We go back here, okay, to the equations. I have a list, VF, VI, A, delta T, X, okay? I always write that down. Watch what I'm going to do. So VI, VF, A, delta T, delta X. I may or may not fill these bits of information in, okay? But this helps me decide what I need to do. So they say to me it accelerates at 1 meter per second squared for 10 seconds. Ooh, 10 seconds, not, that was seconds, not displacement, okay. And then they say to me, question is how far displacement. That's what I want. Now we go, okay, I want displacement. what should I use? Which equation? So let's go back to our equations and we go, okay, I don't know final velocity. I know initial. I know acceleration. And I know time. That equation doesn't help me because it doesn't have displacement in it. So that's useless for us, okay? I want displacement. I know initial. I know time. I know acceleration. Brilliant. That's the equation I need to use. It's exactly what you do, grade 10s. You go through it step by step. So we go, okay, I want to use delta x equals vi delta t plus a half a delta t squared. I wrote my list so it becomes easy. That's 0. It does it for 10 seconds. It's a half. It's 1 meter per second squared. And it's for 10 seconds. Now it's a math problem, grade 10s. If you show me all the steps, brilliant. If you don't, it really doesn't matter, but I'll show you. 0 times 10 is 0. A half times 1 is a half times 10 squared. 10 squared is 100, so that makes it a half times 100 is 50. 50 meters. Okay? So that means the train moves 50 meters in 10 seconds. Okay? You guys ready to tackle another one? I hope so. So here we go. A bus is going at 30. What did I say? We need to have a list. So VI, VF, A, delta T, delta X. So it is going at 30. It comes to a stop and stops. Stop means that it's going to come to a rest, not moving. Final velocity is 0. And it does this in 5 seconds. What is its stopping distance for the speed? Delta X. Like I said to you earlier, there's lots of ways you can do this. We can work out the acceleration. It's not that difficult. And then use that to work out delta X. You want to make it as simple as possible. Remember, you have an equation that says to us that delta X is equal to VF plus VI divided by 2 times time. So VF, we've said, is 0. Initial is 30. You're going to divide that by 2 and then times it by 5. So 30 plus 0 is 30. 30 divided by 2 is 15. So I have 15 times by 5. 75 meters. Okay? I think we can go to something a little more challenging. All right. A motorcycle has a uniform acceleration. Uniform, grade 10s, same as constant. Okay? Uniform, same as constant, doesn't change. And it has a uniform acceleration of 4. Assume the motorcycle has an initial velocity of 20. Calculate the velocity and displacement, at the end of 12 seconds. So we actually have 2 things to do here. VI, they said to us, was 20. VF, we don't know, but it's one of the things I need to calculate. A is 4. Delta T is 12. And delta X is what we are looking for. Didn't say which order you had to do this in, so it doesn't actually matter, but let's start with VF. You go back to your equations, and we don't want to use an equation with delta X in it. I don't know delta X, so I can't use displacement, but I do have an equation which says to us that VF equals VI plus A delta t, where VI, they said to us, was 20. A is 4. T is 12. 4 times 12 is 48. So we're going to have 20 plus 48, which gives me 68 meters per second. You pretty much could only use that equation at this point because we don't know x. Now they say to calculate delta x. And we go, okay, well, I want to show you that it doesn't really matter how we get round there. We want, so I know this is 68. Ooh, that looks more like 68. When I actually do this, grade 10s, I write this in and actually underline it so that I remember it's something I found. If I can avoid using it, I will, because in case I've made a mistake and then I'd carry it down and things get all hairy. So let's work out delta x without using VF. Okay, we have two equations with delta x in. We have VF squared equals VI squared plus 2a delta x. Okay, it's got VF in it, and I worked it out, so that's not a good idea. We have another one that says to us that delta x equals VI delta t plus a half a delta t squared. So we go, okay, VI, we realized was 20. T is 12. A was 4. And T is 12 squared. I do suggest you work these out separately because you want to make sure you get it right and you want to make sure you don't make a mistake on your calculator. 20 times 12 is 240. I've already worked these out. And a half times 4 times 12 squared is 96 because, no, ooh, no, that's wrong. I just realized. Oh dear. That's because that's not 96. Oh dear.
Oh, you have to get your eraser from the top.
No, I don't need the eraser.
Oh,
I
you
need the
don't
calculator.
Oh, okay, cool.
No,
I think
we'll
it's
find
my
it.
computer.
Yeah, thank you. This is why I have you. Oh, there it is.
And then I think you choose the black one, eh?
Yeah, I think we're going to... Sorry, guys. This is what happens when you...
That's okay. So you guys can get your calculators out. Maybe you can actually do it before Tracy even gets around to doing it. So send us through the answer. If you have quickly typed it on your calculator, you already know your equations. You already know how everything works, basically. So tell me quick, guys. Help us out here. Let us know.
I think I was too quick for them, though.
Okay.
Okay, but let's just erase the 96.
We have some really fast mindsetters, by the way.
No, we
Tracy.
do. I agree. Okay. What I actually did, mindsetters, is when I worked this out, I went and put 4 as my time and went 4 squared. So I got 96. There's not a chance that 2 times 144 is 96. So we've got a half times 4 times 12 squared gives me 288. Much better value. That actually just looks better too. You see, grade 10s, this is why you need to do it step by step, because even I make mistakes, okay? I was in a bit of a rush, so this is my own fault. This is actually complete. I'm sorry, I am
Don't
human.
worry, we'll forgive you. You're human.
Thank you. But at least I picked it up. Could you imagine?
Yeah.
But that's why you do it step by step. And it's also good for me as a teacher, when I see someone do it like this, it's so easy for me to be able to correct those mistakes. Where if you go from here to the answer and you've put it all in wrong on your calculator, then I can't help you, okay? So now we've got 240. I'm not going to try and do this in my head because I'll probably get it wrong. 240 plus 288, and it's 528. No, 588. No, 528. So I can't even read today. Oh, boy. Okay. 528 meters. I want to show you something. As I said to you, it doesn't matter how you get here. Okay? This was one way. This is the way I would prefer you guys to get this answer, simply because I didn't need to use that 68. But what happens if you do decide to use the 68? Then you're going to use this equation. VF squared equals vi squared plus 2a delta x. Now, I'm going to be honest here, grade 10s, I'm lazy when it comes to this. I don't like this equation because I'm going to have to manipulate for x. Now, I'm going to have to do this really quickly. So that's 68 squared. This is 20. 2 times, and my acceleration was 4. Okay, it's still delta x. Sorry, delta x. So 68 squared is 4,624. 4,624. 20 squared is 400. This, sorry, not yet. Let's do this. 400 plus 8 delta x. I'm sorry, we're running out of time. So I'm going to give 4,624 minus 400 gives me 4,224 equals 8 delta x. Now watch. 4,224 divided by 8. Oh, look at that, 528 meters. Okay, so it doesn't matter. 528 meters. So it really doesn't matter which way around you do it. Why don't I want to do this? Because I might have made a mistake with F. Okay, with VF. And I think I'm done.
Yes, thank you,
I think it's time for
Tracy.
coffee.
I think
Oh
it
my
may
goodness.
be time for a little bit of a nap for you.
I think so. It's been a long day.
I know,
Thank
I
you,
can
grade
imagine.
10s.
Thank you, Tracy. That
you're
was awesome. Thank you, grade 10s. I know that you guys enjoyed it because I can see what you've written on the page. So, thank you for that. And thank you for joining us. Thank you again to Liberty, guys, for bringing us such an awesome show. Grade 11s are up next. Bye-bye, grade 10. See you next time.